Okay, so I'm a little embarrassed because I did a live stream just prior to this one, and I did just realize that that the orientation of the video was 90 degrees off. So if anybody's watching here, if they could give me some feedback about whether I have the correct orientation for this video. So I'm just trying to get things straightened out here for you so you can get something out of this this video here. So first off, my name is Mario with Mario's Math Tutoring, and if you have questions as we're going through this huge SAT math review, go ahead and jump in the chat, ask me a question. I certainly am welcome to that. Again, this is my first live stream here, so I'm still getting used to the application here, so bear with me, and we'll try to offer you some good value here as we go through this. So first of all, let's just get started, and we'll talk about parabolas as they tend to appear on the SAT, as we've been able to identify so far by looking at some of the officially released new SAT math exams, as you can find on the SAT College Board site. So first of all, let's just go through the three different types of parabolas, and again, feel free to jump in if you have questions or comments. I'll try to answer them as I go through. So Elias, Solid, I appreciate your videos. I appreciate you for tuning in. How's the audio quality, and how is the orientation of the video? Is it showing up correctly on your screen? Can you let me know about that? Okay, so let's get right into this. So first of all, what I'm going to do here is I'm going to oh, it sounds good. Okay, the living word. I appreciate you chiming in on that. I appreciate that a lot. Okay, good. And how's the orientation? Is the video in the correct orientation? Before I had done this video, it was actually 90 degrees off. So hopefully this is in the right orientation now. So let me know about that if you could. But let's get right into it. So the first one I want to show you is just y equals 1 x squared. Okay, it's good. All right, thank you for the living word. I appreciate that. Minus 2x plus 1. So what we're going to do is we're going to identify what type of form is this of the quadratic of the parabola. Well, you can see it's in this ax squared plus bx plus c form, and this is oftentimes referred to as the general form, or just some books will call it the standard form, but that's oftentimes confused with the vertex form. So I usually just call this the general form. But what we're going to do is we're going to find the vertex, and we're going to graph this parabola and go from there. So can anybody tell me what the equation is for the vertex of the parabola when it's in this form? When it's in this ax squared plus bx plus c form, does anybody know the how to find the coordinates of the vertex? Well, what you want to do and what you want to memorize is this formula right here. It's x equals negative b over 2a. Okay, so what you do is when you see that negative b, it just means it's the opposite of b. Okay, so it's negative b over 2a. So what we're going to do is, this is a is 1, b is negative 2, and c is positive 1. So negative b is going to be the opposite of b, which is positive 2, okay, divided by 2 times 1, okay, since a is 1. And okay, Raj Patel, thanks for jumping in. Okay, we're going to go through some different questions, and if you have other questions at the end of this review of parabolas, we'll open it up to questions. So if there's things you want to talk about, we can do that as well. And I just want to mention that I do have that huge SAT math review course. If you guys are interested, there's a few free previews that you can check out. If to see if it's something that's of interest to you, you can go over onto my About page on my Mario's Math Tutoring YouTube channel. So check that out if that's something that you think would be useful. But continuing on with this, you can see 2 divided by 2 equals 1. So the x coordinate of the vertex is going to be 1 comma something, right? So how do we find that y coordinate of the vertex? Raj Patel is asking us how much time we're going to be online for. I think maybe around, I don't know, maybe 20 minutes, half hour, something like that. This is my first live stream, so I'm going to try to keep it relatively short, but we'll just see how long it goes and just kind of take it from there. So then what you want to do is you want to take that 1, and we want to find the y coordinate. So how do you find the y coordinate of the vertex after you found the x coordinate? Well, what you want to do is you want to go ahead and put it back in for x here. Okay, so if we put 1 in for x, we get, let's just do it down here so people can follow along. So it's going to be 1 times 1 squared minus 2 times 1 plus 1. Well, 1 squared is 1 times 1 is 1. Okay, minus 2 times 1, which is 2, plus 1 more. Okay, and you can see 1 minus 2 is negative 1 plus 1 is 0, right? So basically what we have here is we have our vertex is 1 comma 0. So now what we're going to do is we're going to graph that parabola. So I'm just going to draw this freehand. I don't have some graph paper in front of me at the moment, but we're going to locate the vertex, which is right 1, up 0. Okay, and then what you want to do is you want to draw on that line of symmetry. Okay, it's that vertical line of symmetry. That's what divides a parabola in half, right? So if you take the mirror image over this line, you're going to find some corresponding points. Okay, so what we're going to do now is we're going to plot some additional points. And so what I'm going to do is I'm going to pick an easy point. And what you can do is you can just make a table like this. And the easy point to locate is the y-intercept. All you have to do is set x equal to 0. And that'll give us the y-intercept. So I'm going to go back over here. I'm going to put 0 in for x. And if you do that, you can see that this is going to make this 0, it's going to make this term 0, and we're going to end up with just with positive 1. So you can see that our y-intercept is going to be at 0, comma 1. So I'm just going to go up 1, and there's a point. And then if I reflect it over that line of symmetry, there's a corresponding point. So now we've got 3 points. We can get a pretty good idea of what our graph's going to look like, right? Okay, it's opening up, and you can see that we have a minimum value, or the lowest value here at y equals 0. Okay, so this is the general form of a parabola. Definitely something you want to know and understand for the SAT. But now what we're going to do is we're going to go over to the other forms of the parabola. But before we do that, does anybody want to jump in and ask a question about how this general form of the equation of a parabola works? Go ahead and feel free if there's anything you want to ask me. See, basically this a value tells you whether it's, if it's positive, it means it's going to be opening up, okay, like this. If it's negative, it's going to be opening down like this, right? And the larger this a value is, like if a was 3, for example, what that would do is it would stretch the graph, making it narrower. And if it was smaller, like say like a half or a fourth or something like that, it would make the parabola wider, okay, so it's compressing it. So that's the basic idea. So when you see these parabolas, you know that it's a parabola because the highest degree is 2. It's an x squared type graph. Okay, so that's the idea. So I think what we'll do now is let's go on to some of the other forms of the parabola. Let's go on to the vertex form now. So the vertex form is going to look something like this. It's y equals a times x minus h squared plus k. Okay, and the vertex is going to be at h comma k, right? And again, this a value is just like the a value in the last problem that we were working with. It's what stretches the graph or compresses the graph, or if it's negative, it reflects the graph over the x-axis. So a simple example would be something like this. Say we wanted to graph y equals negative 2 times x plus 1 squared minus 4. Okay, so can anybody tell me the coordinates of the vertex? Okay, so what do you think? So where is the vertex of this parabola? Well, if you take a look, you can see this h value here, that's the x-coordinate. The k value here is the y-coordinate. And the thing to remember is that the number that's grouped with the x, okay, somebody just jumped in. Raj Patel says negative 2, Obata Camus, I apologize if I'm mispronouncing, says negative 1, negative 4. Yeah, you're absolutely right. It's negative 1, negative 4. And the thing to realize is that the one that's grouped with the x has the opposite sign. So it looks like it's plus 1 here, but it's actually the opposite sign. It's going to be negative 1, and the y-coordinate is going to be negative 4. Okay, so the y-coordinate has the same sign, okay, and the one that's grouped with the x has the opposite sign. Okay, so what we're going to do now is we're going to go ahead and graph this parabola and graph the vertex, negative 1, negative 4, so I'm going left 1, down 4. I'm going to sketch in that axis of symmetry like so, all right? And then what I'm going to do is I'm going to pick some easy values. And some easy values, what we can do is we can focus in on this a value and graph y equals negative 2x squared. Okay, this is called the parent function. It's basically what gives you the general shape of the graph, whether it's opening up or it's opening down, and how narrow it is or how wide it is. So what we can do is we can make a table, an xy table like this, and we'll just pick some easy values like maybe 1 and 2. So if I put 1 in for x, I get 1 squared is 1 times negative 2 is negative 2, and then 2 squared is 4 times negative 2 is negative 8. But now here's where students go a little bit off. instead of graphing from the origin, I'm going to graph from this vertex point right here. So I'm going to go right 1 and down 2, okay? And then I can take the mirror image over the line of symmetry like that, and then I can also go right 2 and down 8. I'm just going to estimate this one because it's going a little bit off our graph. And then if I take the mirror image over that line of symmetry, I get a corresponding point. So it gives us a pretty good sketch, a pretty good idea of what the parabola looks like right there, okay? So you can see this graph has a maximum value at the vertex, and that's going to be at -4, and it just continues to go down from there. So that's going to be the maximum, the highest that the parabola reaches. So what do you think? Any questions at this point about the vertex form of a parabola? This is the form that you want to familiarize yourself with, and just get used to recognizing that the x-coordinate's the opposite sign and the y-coordinate has the same sign as that h and k here above. So any questions about that? Anything you want me to talk more about in regards to the quadratics there for the vertex form? Okay, so if you're just joining us here, feel free to jump in with any questions you might have. We can talk more about parabolas here. I'm going to do one more example talking about the intercept form now of parabolas, and then we can open it up to questions that you have just regarding the SAT math section. Okay, Obata is asking, how do we convert from standard form to vertex form? Okay, that's a great question. Okay, so let's go back to this problem that we were doing here just a minute ago. See, this is in the standard form right here, okay? And what we're going to do is we're going to convert it to the vertex form. That's what you're interested in, right? So let's go ahead and make some room down here. So what you would do is you would say y equals x squared minus 2x plus 1. Okay, and there's two different ways to do this. One way to do it is called completing the square. And what you do is, and there's different ways to do this as well, but what I'm going to do is I'm going to move this 1 just a little bit over to the side, just to kind of get it out of the way. So I'll show you that. So y equals x squared minus 2x plus 1. And then what you do is you take half of this coefficient in front of the x term. So half of -2 is -1. And if you square it, that's going to be +1. But you can see out of thin air, I'm adding 1 to the right side of this equation. I don't want to change anything or change the value of the right side, so I'm going to counterbalance that by subtracting 1. Okay, so then what we're going to do is we're going to factor this quantity right here, which works out to be a perfect square, x minus 1 squared. And over here, the 1 and -1 actually cancel each other out. That's just 0, but I'll just write in plus 0. So now you can see that this is in the vertex form, and our vertex is going to be over here at +1, comma 0. And you can see that's where the vertex was when we graphed it the first time, right here, 1, 0. Okay, so that was an excellent question. So converting from the general form to the vertex form, you can just use the completing the square technique. The other thing that you can do is you can use the vertex over here, C1, 0, and if you know that vertex form, okay, which we just talked about, which is the y equals a x minus h squared plus k, you can put the 1 in for h, okay. Okay, Raj says, I understand it now. Wow, it was so simple, and I was stressing myself out. Okay, well, okay, don't get stressed out. We'll try to clear things up here in this video. And then the k value is going to be +0. And the thing to realize is that this a value is going to be the same a value as we have up here. See how a is the number in front of the x squared term? That's 1. That's going to be the same a value right here, so this is also 1. So you can see you can either just go ahead and substitute in that vertex the h and the k, or you can do that completing the square method that I showed you down here. So those are some great questions. Definitely you guys are asking some good ones. So any other questions that you want to ask regarding what we've covered so far about parabolas and graphing parabolas and finding the vertex and the different forms? We still have one more form to go, and that's the intercept form. Okay, Obata says thanks, so you're welcome. I'm glad that helps. Let's talk about the intercept form now. So we're going to cruise on over to another example, and we can always come back if you have more questions about that. But this third form that we're going to be talking about is the intercept form, and it can be written in this form like this: y equals a times x minus m times x minus n. Okay, and what you can see is this is basically like a factored format. Okay, it's like in a factored form. And so what you do is, I'll give you an example. Like, say for example they gave us a problem like y equals 3 times x minus 4 times x minus 2. Well, what you can do is you can set these factors, these groups, equal to 0, right? And if you do that, what do you get? You get x equals 4, and you get x equals 2. And so what you would do from there is you would go ahead and plot those x-intercepts. Okay, that's going to be at positive 2 and positive 4. And then what you want to do is you want to draw on that line of symmetry. The line of symmetry is going to be halfway in between those two x-intercepts. So if you're not sure what it is, you can add them together and divide by 2. So 6 divided by 2 equals 3. And this is the line x equals 3. Okay, so that divides the parabola in half. Okay, so from there, what you can do now, you know the x-coordinate of the vertex. It's going to be right along that line of symmetry. You just have to take that x equals 3 value, put it back in for x here, and you can solve for the y-coordinate of the vertex. So if we do that, 3 minus 4 is negative 1, 3 minus 2 is 1, and if we multiply by 3, we get 3 times negative 1 times 1 is negative 3, so that's going to be our y-coordinate of our vertex. Okay, so are you with me so far? Any questions about how we found that vertex? So that's the key. So you found the vertex, you've got the two x-intercept points, and with those 3 points you can get a pretty good sketch of the graph. Now, again, if you look at this a value, if the a value is positive, remember the graph opens up. If the a value is negative, that means the graph is opening down, right? And then what the 3 does, the larger this a value is, the more that it's going to stretch the graph. And what that does is it makes it narrower. The smaller that it is, if it's like a half or a fourth, it's going to make it wider, okay, like that. All right, so again, this graph has a minimum value because that's how low it goes, okay, but it doesn't have a maximum value. It keeps going up to positive infinity. So far we've basically gone through the 3 different forms that you would likely see the equation of a parabola on the SAT or a quadratic, however you want to say it, either the intercept form or the vertex form or that general form. So if anybody has any questions about what we just did so far, okay, let's see. So Amoyamen, I'm sorry if I pronounced your name wrong. It says, how do you factor when the a value is greater than 1? Oh, okay, so how do you factor when the a value is greater than 1? Okay, that's a great question. Well, what you can do is, okay, let's see if we can look at an example here. Say, for example, you had, let's just say it was, let's say, 3x squared. I'll try to make up a good one here for you. So say it was like, let's say something like this, and what should we make this value? So let's just say that this was, let's see, how about 13, like that, okay? So how would you factor something like this? Well, that's a good question. Actually, let me pick a slightly different example here. Let's just say it was like 2x squared, and let's maybe make this minus 15, and let's maybe say this is let's say plus 7x. Okay, is that a good example there? So you can see the a value is something other than 1, and you're wondering how to factor it, right? Okay, well, there's a couple different methods. Some students, they like to do the guess and check method, but I find that for a lot of students, that can be a little bit challenging, especially when the numbers are larger. So what you can do is you can take this 2 and you can multiply it by the negative 15, and what you do is you have to ask yourself what 2 numbers multiply to negative 30, but they have to add to the middle coefficient, which is positive 7. So can anybody tell me what 2 numbers multiply to negative 30 but add to positive 7? What would that be? It's like a riddle. This is the toughest part about the problem, but basically if you can figure out this, you've got it. So basically you can see 10 times negative 3 is negative 30, but 10 plus negative 3 equals 7. And so then what you would do is you would split this middle term into 10x and negative 3x, okay, and then bring down the first and the last term like so, all right, and then all you have to do now is factor by grouping because you've got 4 terms. So you're going to group the first 2 and you're going to group the last 2, and these are actually added together, okay, these 2 groups in parentheses. And then what you do is you factor out the greatest common factor. So I'm going to factor out a 2x, which leaves us with x plus 5, and I'm going to factor out a negative 3, which leaves us with x plus 5. And you can see now you've got this x plus 5 in common. If you factor that out of this group and this group, you're going to have x plus 5 times 2x minus 3, and now you've got it factored. And again, the nice thing about factoring is if you FOIL all these together, multiply these together, So Raj says this is factorization is easy when you teach, sir. Okay, well I appreciate that. And you guys can just call me Mario. You don't have to call me sir or anything like that. I just want to give you some information so that help you score better when you take the SAT and help you in your math class. So I definitely I'm glad you guys are getting something out of this. So I think what we're going to do, we're at the 20-minute mark right now. I think what we're going to do is we're going to kind of wrap up this live stream. This is my first experience with live streaming, so I hope this was helpful. And if you have more questions, definitely check out my YouTube channel, Mario's Math Tutoring. And if you're getting ready to take the SAT, definitely check out my huge SAT math review video course. I also have one for the ACT. It's the huge ACT math review video course. And you can find those on my About page on my Mario's Math Tutoring YouTube channel or on my website, mariosmathtutoring.com, or you can see it on the header, the channel header at the top of my YouTube channel. So that's basically what I would recommend for right now. If you're interested, check that out. Otherwise, stay tuned for more live streams. I'll probably try to do these at some type of regular interval. I'm not sure yet how I'm going to set that up. But I think what we're going to do is just kind of wrap things up for today. Definitely check out those videos on my YouTube channel. I have a number of videos regarding the SAT as well as the ACT, and then things covering the topics that we covered today, such as completing the square, factoring, graphing parabolas. So if you want to review those concepts more, definitely go ahead on over there and check those out when you like to do that. So all right, enjoy the rest of your day. Thanks for tuning in, and I look forward to helping you in the future, and we'll talk to you soon.